Namaste to all my dear students. How are you? Today I am giving you very important chemical reaction, organic reaction you can say, and organic reagents, which are very necessary for knowledge as well as examination viewpoint. So today is important organic reactions and reagents. So these all are very important for you, for knowledge as well as what you see examination viewpoint. So first one is dehalogenation. Dehalogenation, or you can say simply elimination reaction. So what you see? Dehalogenation, or we can say elimination. So always keep in mind, D means removal of what you see halogen and hydrogen. Dehalogenation. It means dehydrogenation, or we can say what is the elimination reaction. So what we see over here, D means always keep in mind removal of hydrogen as well as halogen. That is known as dehydrohalogenation reaction, or simply what we say elimination reaction. So how can you define? So when alkyl halides are heated with alcoholic means in presence of solution made in alcohol, alcoholic solution of maybe sodium hydroxide, maybe potassium hydroxide. So we get alkene compound by halogenation reactions. Look at example. So what you see? H, suppose X. X may be chlorine, maybe bromine, maybe iodine. Yes. So when this is treated with alcoholic means solution made in alcohol. Alcoholic solution of what you see, maybe NaOH or KOH. When it is heated, so what happens over here? So also keep in mind the halogen, in which halogen is attached, that is known as alpha, and next one is known as beta, gamma, delta, like this. The halogen which what you say combines with carbon, so first carbon you can say, so that is known as alpha carbon, second is known as beta hydrogen. So what happens over here? So you know that is Na. Na means electrophile, which means what you see nucleophile. That is electrophile. No, that is nucleophile. Nucleophile, you know. So atom or group of atoms containing negative charge. So what happens over here? So this nucleophile, so it takes this hydrogen, beta hydrogen always, not alpha hydrogen. So this, what do you say, OH takes up, yes. So this nucleophile reacts with this hydrogen. So what happens? So this bond comes over here, yes. When this bond comes over here, so what happens over here? 1, 2, 3, 4, 5 is possible? Not possible. So that X, what do you see? Removes from this alpha carbon. Again, so this nucleophile attack over this hydrogen. So what we have? Water molecule. And that bond comes in between this carbon and this carbon. This carbon and this carbon. So what happens over here? So here double bond develops, and when double bond over here, so 1, 2, 3, 4, 5 is possible? Not possible. So what happens? So that X leaves from this carbon. So what product we get over here? We get carbon, carbon, double bond, H, 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 plus what do you see? NaX, sodium halide, plus OH reacts with hydrogen. What we have? Water. Yes. So what? There is formation of alkene. Yes. So what happened over here? So when you talk about the original meaning of this, what do you see? Dehydrohalogenation. So what do you see? So removal of, what do you see? Hydrogen as well as halogen. Always in presence of alcohol. That is very important point over here. So solution made in alcohol is known as ethyl alcohol, generally we use. So what you get? Alkene, sodium halide plus water. So this whole reaction is known as dehydrohalogenation, or we can say simply elimination reaction. So you are clear? So we take, that is the general reaction. That is general reaction. So when we take simple example, so when we take very simple example like this, so what is this? Bromine, H, 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 H. So what the name of this compound? Bromo. And bromoethane, that is alkyl halide. So when that is treated with AlC, means alcoholic. So maybe what you see, we can use sodium iodide or KOH. So in this case we use, what do you say, same NaOH solution. AlC means solution made in what is alcohol, AlC. And when it is heated, so what do you get? Again plus minus, so that react with, what you see, hydrogen. Yes, nucleophile, and that bond comes over here, and that bond leaves from this, what is the carbon, and that is known as alpha carbon, that is known as beta carbon. So generally removal of beta carbon, not the alpha carbon. Yes. So what happens? What do you get over here? C double bond H, 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 H plus NaBr plus what you get? Water. So that is known as ethene. Yes. So there is, what you see over here? So there is formation of alkene over here. So always keep in mind, yeah, we can say principle of this reaction is like this. When we talk about the dehydrohalogenation, so principle is like this: to convert alkyl halide into alkene compound. For example, conversion of, generally ask you in examination, conversion of ethyl bromide into ethane. So we can use. So one question is asked in examination. So what is dehydrohalogenation? Give suitable example. Next one, what the principle of this one? To convert alkyl halide into alkene compound. Yes, so I have already given you general reaction as well as examples. So we can convert bromoethane to ethene compound. So that is very simple, very useful reaction for examination. Yes. So next one is, that is about what is dehydrohalogenation. So question is like this. Question is asked like this: what is dehydrogenation reaction? Give suitable examples. I think you can write a definition of dehydrohalogenation, then you can give what you see suitable examples. Very important for examination. Yes. Next one is, so I'm talking today important reaction as well as reagent. So now second one is, what is see decarbogylation. Decarbogylation. Question is, what is decarbogylation reaction? Give suitable example. It's very important. So at first we have to know what is decarbogylation reaction. So decarbogylation reaction, it means removal of carbon dioxide gas is known as decarbogylation reaction. Yes. So always keep it. D means removal. What type of compound? Carboxy, but means what we see? Carbon dioxide gas is known as decarbogylation reaction. Now example are like this. What you see? When sodium or potassium carbogylate, better to remember, carbogylate compound is heated with soda lime keep in mind soda lime means it is a mixture of sodium hydroxide and quicklime, CO. We get alkane compound by decarbonylation reaction. We know the meaning of decarbonylation means removal of carbon dioxide gas. So example is like this. So what you see? Sodium or potassium carbogylate. So RCONA. So that is known as general reaction, we can say. So that is known as sodium carbogylate. Why? Because if we H over here, so this H is substituted by sodium. So sodium carbogylate is heated with soda lime. Soda lime is the mixture of NaOH plus what you see? CO. And what the function of CO over here? To remove the water over here. So when heated, this is the sign of heating. So what do we have? We get RH. R means no alkyne. And what do we get? Sodium carbonate. So that is sodium carbonate. RH means alkane. Also you know R means alkyl. Alkyl means its general formula, better to say, its general formula is Cn twice N plus 1. So one hydrogen is less than what you see? Alkane is known as alkyl. I have already told you about this one. So this is the general reaction. So example are like this. So what process takes place over here? So removal of this CO2 and that combines with what you see NaOH and what we have? Sodium carbonate. Yes. So what you see? Example are like this. So what you say? R. Suppose CH3. What the name of this compound? Sodium acetate. When this is heated with soda lime, so what do you see? So what do you get? CH3 and H. So what do we have? Methane plus what you see? Sodium carbon. That is methane. So always keep in mind what the R over there. If methyl, what do you get? Methane. If ethyl, what do you get? Ethane. If propyl, what do you get? Propane. So keep in mind. So what we have? Next, suppose C2H5CONA, that is sodium propionate. Propine come from the propionic acids. So what we can say? Sodium propionate. So what do you get over here? Sodium propionate, when that is heated with soda lime, it is the mixture of sodium hydroxide heated. So what we have? So what the alkyl over group over here? C2H5. What the alkyl group over here? CH3. If methyl, what do you get? Methane. If ethyl, what do you get? Ethane plus side product is always same. So what type of reaction it is? Decarbonylation, we can say. So that is ethane. So I think you have clear. So any alkane we can prepare by this method. So one aromatic compound like this, C6H5CONA. If H over here, so that is benzoic acid. So what the name of this compound? sodium benzoate. So when this is heated with soda lime, so what do we get again? C6H5. So what do we have? C6H6 plus sodium carbonate. What do we get? Benzene. That is aromatic compound. That is aromatic compound. So always keep in mind, if methyl, what do you get? Methane. Ethyl, what do you get? Ethane. If phenyl, that group is known as phenyl, or we can say aryl. So always this is the C6H5 means phenyl, or we can say aryl. So I think, so you in examination ask you what happened? What happened when sodium acetate is heated with soda limes? What do you get? Methane. What happened when sodium propionate is heated with soda lime? What do you get? Ethane. What happens when sodium benzoate is heated with soda lime? What do you get? Benzene. So generally, ask in what happens. Sometimes ask you write down the reaction and you have to complete the reaction. So I will give you some model over here. So I think we have clear what are the decarbonylation. Decarbonylation meaning removal of carbon dioxide. So what do you see? This carbon dioxide remove and react with sodium hydroxide, and what you get? Sodium carbonate. So I think you have clear what is the decarbonylation reaction. First one is dehydrohalogenation reaction. Next one is third one. Third one is, what is, all are important. What is Beer's reagent? Give its uses. Give its use. What is Beer's reagents? First we have to know what is Beer's reagent. Beer, the name of the chemist. Beer's reagent. So generally ask you examination. So Beer reagent means 1% alkaline solution of potassium permanganate is known as Beer's reagent. Why it is? What the usage? It is used to detect carbon-carbon double bond or carbon-carbon triple bond present in unsaturated hydrocarbon. Unsaturated hydrocarbons. Very, very important reaction and generally ask you examinations. What is Beer's reagent? So we have clear 1% alkaline, 1 piece out of 100. How much? 1% alkaline. Alkaline means sodium hydroxide, we can keep what's potassium hydroxide of potassium permanganate is known as Beer's reagent. What is the usage of this one? It is used to detect carbon-carbon double bond or carbon-carbon triple bond present in unsaturated hydrocarbon. So generally also asking what you see, what happens It's very important. So when 1% alkaline solution of potassium permanganate is treated with ethene gas, we get colorless ethylene glycol compound by oxidation process. So what do you see? 1% alkaline solution of potassium permanganate is treated with ethene gas. We get colorless ethylene glycol compound by oxidation process. So what we see over here? So in this case, at first, potassium permanganate, that is potassium permanganate alkaline solution, means potassium hydroxide solution is added over here. So what we get? K2MnO4 plus H2O plus nascent oxygens. What do you get? That is known as potassium manganate. So when you balance, what we have? 2, 2, 2. Yes, that is balance. So what do you get? Potassium permanganate react with potassium hydroxide. What do we get? Potassium manganate plus water plus oxygen. Now ethene gas, that is ethene gas, when that is treated with H2O, nascent oxygen, we are already observing over here. So what we get? Nascent oxygen. So that come from the 1% alkaline solution of KMnO4. So its color is what we see pink in the starting. So you know, potassium permanganate color is what we see pink at first. Yes. So what we get over here? Colorless compound CH2OH. So its common name is ethylene glycol in IUPAC system. What do we? How many carbon? 1 carbon, 2 carbons. What do we have? Ethane 1,2-diol. Ethane, how many carbon? 2 carbon. Ethane, in which position we have? First carbon and 2 carbons. What we have? 1, 2. How many ol? Ol means secondary suffix of alcohol. So what we have? 1,2-diol. So color is what you see? Colorless. So very, very important. Generally asked in examination. So comparative idea. So in this case, ethene. Now when this is treated with ethine, that is the double bond. When what you say CH triple bond CH, that is known as ethine. So that O that come from the what you see alkaline solution bears reagent. So what have it come from the 1% alkaline solution of KMnO4. So at first what we get? Pink color. So at first what we get? CHO. So common name is glycosol, and what we say? IPAC system ethane diol, 8 ethane 2 carbon. In this case we never numbering 1 and 2. Why? In this case only 2 major functional group, no other subsidiary what we say carbon. So we never write 1 and 2. So ethane diol, yeah, you can say glycosol. That is also known as, it is further oxidation. It come from same. Do means same reagent. So what do you get? COH. So what the common name of this compound? Common name is oxalic acid. That is common name oxalic organic acid. And IPAC system what we have? In this case also we cannot write what 1 and 2. Why? In this case 2 major functional group. Yes, so we cannot write over here. So what we have? IPAC system, ethane 2 carbon over here, ethane dioic acid, IPAC. So I think that is colorless. At first what we have? Pink color. At last what we get? Oxalic acid. I think. So you can write what is the Bayer's reagent, what are the uses, and what happens when ethene gas is passed through Bayer's reagent or ethine is passed through Bayer's reagent. So that is very important, generally asked in examination. So what I have told you, at first potassium permanganate gives nascent oxygen. That nascent oxygen was oxidized, was ethene, and what we have? Ethylene glycol. That is the common name. IPAC system, ethane 1,2-diol. Yes. So that is about the Bayer's reagent. I think you have clear. So any question we have about this? Fourth one is catalytic. So all are very, very important. Catalytic hydration of catalytic hydration. Hydration means, you know, breakdown due to water. Catalytic means in presence of catalyst. So when ethine is hydrolyzed with 42% sulfuric acid, 1% mercuric sulfate, at 60 to 80 degrees centigrade. At first we get vinyl alcohol compound, which on further tautomerize, which on further tautorize, we get ethanol L compound. So what do you see over here? Example are like this. Example, better to say. So what do you see? See, that is ethine. You know, so when this ethine is reacted with what do you see? Water, it gives S plus and OS minus that come from the what do you see? 42% sulfuric acid, 1% mercuric sulfate at 60 to 80 degrees centigrade. So that is the what you see catalyst. Mercuric sulfate in this case known as what you see catalyst. So hydrolysis in presence of HgSO4. So at first what we get? That is, so always keep in mind. So carbon-carbon double bond is known as vinyl. So in this case alcohols, what we can say? That is vinyl alcohol. Yes. So tautomerize, I have already told you, tautomerize. So internally rearrangements over here. So that bond comes over here. So what do you see? 1, 2, 3, 4, 5 is possible over here. And also know where there is pi bond, double bond, what we have? Pi bond. And pi bond is always delocalized in nature. So what do you see? That pi bond comes over this carbon. So when this pi bond shift over these carbons, what we see over here? That is tautomerase. And what do you get? When this H comes over here, negative charge. So what do you get? CH3, so what do you get? CH3, COH. That is ethanol compound. Again, so what do you see? Internal rearrangement over here. So that bond in between O and H. So that bond comes over this carbon and oxygen. So what develops over here? Double bond. If we have double bond, what do we see? 1, 2, 3, 4, 5 is possible? Not possible. So where there is double bond, what we get? Pi bond. So that pi bond is delocalized in nature. So that shift over these carbons, what develops? Negative charge. So what do we have? Ethanol compound. Yes. So sometimes ask you, that is very, very important. Sometimes ask you question, conversion from ethine to L, not OL, ethanol. So we have to write this one. So in conversion we have to not write the language, only we have to give the reaction. So I will talk about this different type of conversation. So I think you have clear what is catalytic hydration. Hydration means, you know, treatment with water in presence of catalyst. What the catalyst over here? Mercuric sulfate. So what type of reaction it is? Catalytic hydration. It's very, very important. Sometimes ask you what happened. Yeah, what do you mean by catalytic hydration? Sometimes ask you, how can you convert from ethine to ethanol? So then we have to write all these reactions. I think you can write. Yes. Next one is what to say? Polymerization reaction. Polymerization reaction. So question is like this. So at first we have to know what is polymerization reaction. Yes. So what we see, formation of polymer from simple single molecule that is also known as monomer at certain condition of temperature and pressure is known as polymerization reaction. So look at the example over here. Example are like this. For example, one example, A, better to say. So what we see, three molecule. So what is C triple bond H, yes. So how many molecules? 3 molecules. So what we see, that bond comes over here, that bond comes over here, that bond comes here. So what we see, 3 molecules of ethyne, internal rearrangement. So what we see, red hot tube of iron at 450 to 500 degrees centigrade. So process is polymerization, and after polymerization what we get? Double bond, double bond, double bond. So that is known, we can write simply C6H6. That is benzene. Yes. So what we see, 3 molecules of simple molecules of ethyne when passed through red hot tube of iron at 450 to 500. So what the process over here? Polymerization. And what we get? That single molecule, and that is known as benzene, or we can say aromatic compound, that is also known as aromatic compound. First example. Next example is like this. Second example is AB. What is C? That is ethene. So when that is heated at what is it, 200 to 400 degrees centigrade and 2000 atmospheric pressure, process is what you see, polymerization, that is yarn molecule. Yes. So what you get? That is with the H. So double bond convert into single bond, and that is the long chain. So that is known as polythene. You know, polythene bag. So many things we get from the what is a polythene. So N more than 1,000. Single molecule is known as monomer. When this is passed, you are treated with 200 to 400 degrees centigrade and 2000 atmospheric pressure. So at that temperature, what is it? Polymerized, low temperature and high pressure. So what you get? Polythenes. You know polythene bag, polythene, what is a plastic? So many things you can prepare from the what is a polythene. So this is about what is a polymerization. So thank you all for visit this video, and rest is okay. Next I will come with new video. That is that what I have taught you is very important for knowledge as well as examination viewpoint. Yes.